For our basic circuit, we've talked about 4 components that are needed: the power source, a switch, the load, and the conductor. I want to add one more to that, and that is called a fuse. So a fuse is a protection device. It is there to protect the circuit, the wiring, the integrity of the entire circuit, and also the load. So let's imagine we have a circuit with a light bulb, and that light bulb is going to draw 2 amps of power. What they do when they design a circuit is they put the wiring, the thickness of the wire, to be able to handle the amount of amperage. So think about a water hose, right? A fireman's hose needs to be much bigger to be able to handle all the water that's going to be going through it, as to where a garden hose, much smaller, because you're not going to be pushing that much volume. So the same thing for a circuit. Well, what can happen is if a circuit becomes overloaded, too much amperage is trying to push through the wiring, it can actually get extremely hot. It can actually melt the wires, cause a lot of damage. So we put a fuse on the circuit. If you've ever seen a fuse before, at the very top, there is going to be a number. So this is a 5. This one is a 20. Hard to see, but this one is a 10. What the number relates to is the amount of amperage that can flow through my fuse safely. So on a 20 amp fuse, 20 amps of current can flow and it's perfectly fine. When it exceeds that, what happens is on the inside of a fuse, there is a very small, you can see it, it's a U-shaped wire. If that exceeds the amount of current or amperage that this fuse is designed to allow, it's going to melt this wire, opening up the circuit, not allowing any more current to flow. So instead of your $500 stereo or your $300 seat heater to blow up, it's going to blow this 10-cent fuse. So as you can see, once again, the rating, we need to make sure if you ever have a blown fuse, do not put a higher rated fuse. So a 20, you always want to put a 20 back in. You never want to put a 25 or a 30, something like that. So we can actually test a fuse. So I have my meter here. Let me zoom in a little bit. I'm going to set it up to read resistance, ohms. I have my leads in the proper spot. I have set it up to measure resistance. So let's take this fuse, for example. This one is a 5 amp fuse. So what I can do is I can actually touch the 2 blades with my leads. And what I should see is 0. Absolutely no resistance whatsoever. My current is going to flow. It's bouncing between 0.1, 0.2 ohms of resistance. Very little. So all my current would be able to flow. I have nothing resisting the current. Let's take a look at a blown fuse. This is a 7.5 amp. As you can see, when I touch the 2 blades, it shows out of limit or an extremely high amount of resistance. Again, if I touch my leads together, I should show 0. That's very little or no resistance. When I touch the blades here, very high resistance. I can also take a look, and you can see how the wire is actually broken right there. So this fuse is bad, time to replace it with another one.